Nice. Let's begin. Very excited to meet you. Um, can we all introduce to the audiences? I will go with myself. Um, I'm now currently a postdoctor in Institute of Neuroscience, Chinese Academy of Science. My current study is based on neuroscience coding theories, and I'm also doing some like video games to study how monkeys play the games and do the strategy learning and strategy selection. This is my current you know scientific interest. Uh, let's go with maybe Andres. Can you
Yes, hi.
yeah, Andrew.
Good morning or afternoon to everyone.
Hmm.
My name is Andrea Benucci. I'm a principal investigator in Riken in Japan, which is located. Riken is located very near Tokyo, not exactly in Tokyo. And my lab is interested in perceptual decision making. We're using experimental techniques as well as some computational methods, and we work with rodents. Next one.
Okay, nice.
Thank you.
E, how are you?
Me first?
Yeah.
Uh, I'm Yisan. I'm currently at Westlake University in Hangzhou, China. So Hangzhou is pretty close to Shanghai if you're not familiar.
Yeah.
And so my lab studies neural circuit basis for social behavior. We're largely a experimental group, also with a lot of computational approaches to basically analyzing our own data. We are using the simple model system of Drosophila melanogaster fruit flies, where there's a lot of genetic tools, so we can study the representations and transformations with neuronal resolution. Yeah.
Nice. How are you?
Hi,
Shanghai.
yes, I'm Sang Li. At the Department of Brain and Cognitive Sciences at Seoul National University here in Seoul, Korea. I guess we will eventually do another round and talk about like a career trajectory. So I'll just briefly introduce my research area. I'm mainly looking at hippocampal memory, like spatial navigation, episodic memory, and how these kind of cognitive mechanisms change in human development and aging and disease. And also currently we're kind of interested in how we can enhance these abilities through training and kind of digital therapy and neuromodulation. So we're in the beginning of my career, I had like both an animal part and a human part to my lab, and now I just have the human part. It was too much to manage. But I can tell you a little bit more about the history of how I got here as we go.
Yeah. I think that's fine. Like we can go like freestyle if you want. Like and we can ask questions to each other.
Yeah, good.
It doesn't have to be centralized.
In order. Okay.
Decentralize the system. Yeah.
Yeah, well, so I started off my studies in the psychology department at Harvard. I looked at cognitive development in children, how spatial cognition develops. And more I became interested while looking at spatial memory in cognitive mapping. And of course, then you become interested in hippocampus and place cells and things like that. So for my postdoc, I went to Italy and I was interested in the development of the hippocampus. And so I was working with animal models. And then I took a junior faculty job for a couple of years in Italy at that same institution. And while I was there, I transitioned from a postdoc to a faculty member there. And then I actually, kind of by chance, had an opportunity to visit Korea and KAIST, it's the Korea Advanced Institute for Science and Technology. And so I moved over to Korea in 2017, and I was in the bio and brain engineering department there. And then just this past semester, I moved to Seoul because that's where my my family lives, at the Department of Brain and Cognitive Sciences here. Yeah, so I kind of went up, all across different countries and kind of different departments, and so I guess I can answer some questions if people have some concerns about those kinds of transitions.
Mm.
Maybe someone else can share their story.
Yeah, a little bit. Cognitive map. Okay, I'm also interested in cognitive map recently. Like I'm studying like how the brain build a model and learn the model, use the model to solve the task, right? This is a kind of several phases for me to think about this question. And I think my major tool maybe it should be some Bayesian inference and Bayesian learning. You need to use the Bayesian learning to learn the model and use the model to do the inference to solve the task. I'm not sure if it's your kind of idea to begin to think about how brain works with the cognitive map.
Or is it a question for me? I didn't know.
Yeah, that's a question for me, for you.
Oh, how do I learn how the mind works?
Yeah, how can you learn the model?
So in development? Sorry.
Yeah, maybe how like how can we come up with a cognitive
I see.
model?
Yeah, so because I looked at both animals and humans, I think, and also the development of these abilities in children, I think it was interesting that I began with looking at human development. The fact that children have a very different kind of cognitive map than adults do. It's not intuitive. We think children are little adults, but they're not, and they're the way they organize spatial information, for example, is different from the way we do. And so from that, I was inspired to kind of understand what's the initial state and how does experience and learning over time or maturation of the brain, for instance, like hippocampus and prefrontal cortex, how does that, change the way we think. And so I was interested in that initial state, and that's why I went back to the animal model to try to understand, what's the evolution of this system, or what are the basics, like the fundamentals that are innately wired in, and then how in human cognition does that become sort of abstract in some sense. And so now, people are studying things like conceptual mapping based on the cognitive map. So I think it's really interesting that initially we think that these things are kind of separate and independent areas, but it's very fluid in some sense. And now, even you like both psychologists and kind of computational modelers and, neuroscientists, everyone can kind of, work together looking at the same area of study. So I think that was kind of cool.
Okay. Yeah, pretty nice. How about Andre? Can you introduce some of your academic trajectory? I'm sure you are having a very enriched experiences, right?
Yes, yeah. Well, I think most of my colleagues have shared very similar wandering around experiences through the academic path. So I started in Italy, so I didn't overlap, however, with Sangin V, but I was also in the north part of Italy. Is that right that you were in Trento?
I was in Trento, yes.
Trento, University of Trento, yeah. So instead I was in the University of Padova, which is very close to Venice.
Mm-hmm.
It is a very old university. Galileo used to teach there. So it was kind of impressive to be in these lecture rooms, knowing that these incredible pillars of science were there in the past. And I was studying physics at that time. Then I got a master in computational neuroscience in Trieste. There's a school there for it's called CISA, International School for Advanced Studies. And then after that, I went to Zurich for my PhD at the Institute for Neuroinformatics. which is under both the ATH, which is the Polytechnic School in Zurich, and under the university as well. So I got a degree that is essentially shared by the two institutions. Then I moved to San Francisco for my postdoc, and I shifted. So my PhD was mostly about computational theoretical aspects, and then in my postdoc, I went into more experimental kind of work. So I worked a lot in the cat animal system, electrophysiology, optical imaging, and after quite a few years, I moved to London, where I continued as a research associate and then senior research associate at the University College of London, still doing mostly experimental work. And then eventually in 2000, across 2013 and 14, I moved to Tokyo, where I opened my lab. That's the trajectory.
Nice. I'm also a physicist, and I think I'm sharing a similar earlier career with you. Like first with like physics in bachelor degree, and then go with computational neuroscience. And I think it's like the transition between the theory to experiment is really hard for me. It's kind of like you need to communicate with different people and to find a common interest and really to find the tools to make the model for them or develop the model with them, right? It's beginning with you need to learn from them and then you need to give them some input. I'm not sure like when you are in this phase, how can you come up with ways to make it to be quickly?
I mean, I can give you my 2 cents.
Yeah.
I think, I mean, in-house, people with both expertise in the same lab is probably the best way. Collaborations with other labs in the same institute or across institutes are also a good way to go. But in my experience, in my personal experience, it is much harder to get something going if you're not in the same room. So
Exactly.
I've seen a few models around of people trying to do that, where they have theoreticians and experimentalists that are sitting, next to each other, and I think that's the way to go.
Nice. Okay, how about E?
My career has been a little bit complicated. So I did my bachelor's degree in engineering, in mechanical engineering automation. And then I went to the industry in the span of a few years, and I became more interested in doing science. So I did my PhD in physical chemistry, which is my first transition. Actually, a very big one, because basically, if you're an engineer, you spend most of the time studying things that are pretty much fixed. So one thing that I realized is that engineers is probably one of the quantitative disciplines that do not study statistics. So when I was a PhD, I spent a lot of time doing experiments. That's where my experimental experiences started. But then I became more interested somehow by reading papers. I became more interested in neuroscience, became interested in how does the brain process information. So after my PhD, I did my postdoc in yet another entirely different discipline. So I went to Janelia Farm, which is my Janelia in Ashburn, Virginia, United States. And I was working on developing tools for calcium imaging. We developed GChem and some of the other tools that are actually widely used these days. And I also spend, in the later stages, spend more time on understanding information processing, basically vision and olfaction in the fly brain. I came back to Westlake in Hangzhou just about 3 years ago in 2018, and now I'm focusing on social behavior and neuroscience basis for that. Yeah, so I transitioned for about 2 times from engineering to physical science to eventually neuroscience.
Nice. I think there's a question about how does working environment and cultures differ across Europe, Asia, and America. I think that's a very good question. Like especially for our sessions, we are all having some overlap between Asia and America and Europe, right? I think we should go with Andre because you are having 3 of them: Europe, Asia, and America.
That is true. That is true. Well, I mean, it is a big question. So there are tons of, it might take hours to discuss all these differences. There are differences in multiple levels in terms of work environments, social environments, interactions between academics, and also in daily life. So, yeah, I mean, it's hard to answer that without going into the specifics of some very clear examples. But I always, I just want to say this, that I found myself somewhat more at home in Japan culturally than when I moved to the States. And I found that surprising because when this is just a personal thing, but you probably know all these stereotypes about Italians and family and mama and passion for food, fashion, and so on. Well, some of these elements, I found them a lot here in Japan, much more than when I was in the States. Especially, I would say that the culture for food that you see here is stunning. I mean, it's really comparable to what I've experienced when I was in Italy. And then similarly, fashion. I mean, people are very fashionable here. They like the big brands. So this is about the cultural impact, if you want. When you move to a country, sometimes you feel, oh my God, I'm going so far away from my hometown. It's going to be such a shock. It was not like that for me when I moved here.
I think it's interesting you say that because when I was born in Korea actually, but I moved to the States and I grew up there from when I was really young. So I'm kind of culturally, at least in terms of like school or professionally, I was, until this point, I was totally, American. And then, although at home, we're culturally Korean, but at the same time, when I moved over to Italy, I think that there was like a bit of a transition, but there was a bit of culture shock. And then when I moved from Italy to Korea, actually what was interesting was that being in Italy helped me transition to Korea. That's kind of
I understand that.
Really realized. Yeah, and I would say one of the biggest things, and this absolutely depends on your PI, and every lab has its own culture and every department has its own culture. But at the same time, there's some things that are shared across. Like there, especially maybe because it was Italy. Maybe if I were somewhere else in Europe, it would have been different. But this Italy to Korea transition wasn't so bad. It was very helpful actually. If I had come straight here from the States, I think it would have been a little bit more of a culture shock. I mean, maybe students here are wondering, what exactly we mean. I'm not sure, we want, like you said, if we want to get into specific examples, but for example, like the interaction between faculty members and students is quite different I think in Asia and the US, for example. Also, the structure of the lab is different. Like I feel like in Korea, there's a lot more graduate students. Like in general, the lab sizes are larger. In terms of grants, there's a lot of funding in Korea. I mean, they invest a lot of governmental funding into research, especially scientific research, and especially brain research these days. For me, one of the things that I don't know if it's something that just happened over time or whether because I can't tell whether it just happened everywhere in the world or whether it happened in this country, because as I transition, every few years. But what I've noticed, especially in Korea, perhaps because they're kind of tech oriented, is that there's a lot of attention and kind of demand for applications. So, for example, neurotechnology or neuromodulation, people are really interested in coming up with new tools. Whereas I feel like things are a little bit kind of, in some sense, slower in a country like the US. And even in Trento, where I was in Italy, there wasn't like this rush for hurry up and let's make some new cool tools. I mean, it was just kind of like very scholarly. And so it depends what kind of environment you feel more comfortable in. If you like, I think Asia is quite driven in that sense. I don't know how the rest of you guys. I mean, I haven't lived in Japan or China or anywhere else, but that's how I felt in Korea.
Yeah, I feel the same. There's lots of sort of pressure to go translational, even for neuroscience. But I actually feel like a lot of neuroscience studies are more intellectual than application oriented. Also, the size of the lab is a huge difference. But my experience has been a little bit different because I was staying in Geneva, where the upper limit of the lab is just six people in the lab. And here, many labs, actually neuroscience labs tend to be smaller. For some molecular biology labs, there are labs with people more than 50 people. Some of my colleagues has massive labs. Yeah, that's a important difference. But for me, the transition from I spent most of my time before postdoc in Beijing, so that was my graduate study and undergraduate study, and then there was postdoc in the United States and faculty in Hangzhou. So I actually feel in terms of culture, the difference is not so big. I feel the difference is more on the level of like the microenvironment, basically the lab you're in. So the style of the PIs or the atmosphere in the school you're in, that actually affect your perception of the culture more than the real culture. Because I guess most of us spend most of our time in the lab instead of interacting with the real world.
Right.
Instead of living in the bubble, and the bubble, I feel it's connected of the world, like whether you're in China, in Korea, Japan, United States, Europe, we're more connected than probably your neighborhood, where they sort of live in a different world.
Yeah, I will use a pyramid instead of a bubble for me. Maybe. Maybe next question. How about I am interested in knowing the motivation behind the wandering trajectories. The idea sounds fun. Okay, I'm also thinking it's funny. And it's if changing institutes affect any long-term projects or ideas.
Yeah, I would. I think there's lots of motivation for changing. I think initially when I went from the U.S. to Italy, it was I was still kind of in this very student and naive mindset. So initially, what I wanted to do was it was just academically oriented. I think I was just looking for the right lab to do what I wanted to do. And so, and of course, I was younger, so I said, okay, let me go live in Italy. And so I had gone, and then I got married, right? So things happen in your family life, and my husband was in the U.S. And so, as a young faculty member in Italy, I had found myself, going back and forth, and that kind of got a little bit difficult. So what we had to figure out was, okay, where can we go together that we can have we can live together in the same city kind of long term. And so while we were kind of exploring these options, we were exploring options in the U.S., kind of back at home, and also in Korea because my parents and his parents were both living in Korea at that time. And so, those kinds of decisions just, make you, and so there's like some sort of compromise you make between family and your scientific interests, I think. And then in terms of institutions, I guess I had gone kind of back and forth from just like a brain and cognitive science department to an engineering oriented department. I was a visitor at Columbia Biomedical Engineering department as well, and also at KAIST. And so I think the engineering departments are a little bit different from the ones that are kind of like in biological sciences in the ways you would expect. I don't think it was bad for me at all because it got me, because before I was just interested in, just the mechanism and I was curious. And so that was enough of a drive for me. But at the same time, it made me realize, as I spent some time in the engineering departments, that, the people who actually study the mechanism should go and, try to create some tools or create some applications for improving these abilities, for example. And so I think it was beneficial in some sense. In the beginning, you don't feel very comfortable, perhaps, but kind of as you learn about different fields or departments, as long as you can kind of come out of that as a learning experience, I think it can add to your research profile in a positive way.
Yeah, I can also add something. If the question by Sabham was specifically research oriented, I would say that the impact is pretty massive. So we all chase opportunities as researchers, and so the wondering is, I think, mostly motivated by the opportunities that present themselves from a research point of view. And when we join a specific research environment, we're strongly influenced by our colleagues and the environment around us, which has some sort of acts sort of as a prior, like there are some sort of directions that are very common among your colleagues. You talk to them and they influence your ideas, and they sort of shift a little bit your interest in that direction. Just to make an example, RIKEN is very well known for their technological development, and they put you in an environment that certainly fosters technological innovation. And so when I opened my lab, it was kind of a natural step to start with technological innovation right away. It was really in the air, if you want, and they give you also the means and the opportunities for that. And this was not something that was there when I first joined. I was not thinking that much about technology when I first arrived here. I had my interest at the computational experimental level. And then, of course, at a personal level, the place is gonna completely change your life, as it did to most of us, probably.
Give us an example of how. Like, how does it change your personal life? Just curious.
Well, for example, when I came here, I had a completely different personal situation in terms of relationship, and now I have a family. I have a kid. I'm married here,
right.
So it's definitely a big change.
Nice. Okay, let's go another question. How much of your time is spent on applying for grants, managing lab, versus doing actual research and thinking about scientific questions? How about let's go with Yi?
Yeah, so that's actually a good question, and I'm still actually trying to figure out how to best appropriate my time. I spend about 30% of my time on grant applications and services, and probably 30 to 40 time on teaching and interacting with the students, like mentoring the students in the lab. I count that together as teaching for the school. And for the rest of the time, I just reading and writing on my own in this office. I I try to minimize the amount of time on conferences because I feel that's actually quite a bit of dedication. But of course, you have to go to a few conferences each year. Yeah, I find it, teaching is actually quite time consuming, especially in the early days, because you have to prepare the teaching materials and mentoring the students, especially starting a lab because, the students started with no experience, so you have to teach hand by hand. That's quite a dedication. But once the labs are up and running and you're familiar with the teaching material, these are more smooth.
Okay. How about the next question? Okay, if I have been working in another country, how hard is it to find positions in academia in your countries? Maybe Andre, do you want to go with it?
Well, I interpret this question as a general question about inter-country possibilities. For example, like you're an American, you come to Rican and then you want to go back, or you're an Italian, go to the States and then want to go back. So it really depends a lot. I mean, some countries value these experiences abroad. Other countries prefer sort of a domestic kind of career where you climb up the ladder and you create connections within always the same environment. It's an academic culture that changes a lot from country to country. I personally think that it's very valuable to move around different countries and experience different research environment and academic environments, but you should not be naive. So you really have to have a very good understanding of where is the place where you ultimately want to be. And in general, when you go to a different country for an experience, my suggestion is to take it very seriously. Don't just go there saying, oh, well, I'm not sure I like it very much, but it's going to be only 2-3 years and then I go back. That's a very bad attitude. Go to a place where, in theory, you can say, well, I want to consider even the possibility of staying here long term. And do your due diligence, try to understand really well where you're going, what are the opportunities also in the long term.
I would like to add to that the fact that sometimes you don't know whether you would want to live there, because you just don't know about it. But I think,
also my question.
But I think the good thing with academia in general is that you're kind of, in any country, you're protected by academia, so you're not going to be like totally very far off in like, of course. Possible, but we do have the luxury of being kind of, all academic cultures are more or less, they're not going to be like very, very, very different. But at the same time, I think it's absolutely true that once you get there, you may think you want to just be there for a little while, but you will definitely benefit from kind of immersing yourself in that environment, understanding, because it's possible that you will have an opportunity to stay there in the long term. So, for example, I had never planned on taking a faculty job in Italy, but when I was offered one, a lot of, then I started thinking, oh my gosh, my husband is in the States. How am I going to continue this academic career? So in the end, I couldn't stay there and keep that academic job, even though I had one. And so then I was, looking for other places as well. So when you go there, I think it is go somewhere you really want to go, and you want to you really would consider staying. And so I think that's pretty good advice in general. Yeah. Because you never know, right? You never know. You might do great, and you might love it, and or you might think you'll love it, and then you might not. but keeping an open mind is important, and learning the language a little bit, and that's also important too.
Yeah.
In terms of Korea in general, so I noticed that in Italy, it's good to have connections in Italy, so to have spent a lot of time there, but at the same time, they do value having spent a few years abroad and then coming back. So you'll see a lot of people who had been abroad who are Italian, and then they come back, right? So, or even, foreigners, if they have, at least, if they are kind of used to Italian culture, or they have an Italian spouse, you see them coming and working in Italy a lot.
Right.
In terms of Korea, they really want people from abroad. I think they really kind of are interested in having kind of internationalizing their academic community, because Korean people in general, I mean, this is a total stereotype, but I'll say they're kind of shy. And so, but they want to interact. And so if you are interested in taking a job here, I think there was another question about, should you contact them and give a talk there in advance? Absolutely. I think any Korean institution would love to interact with you and entertain the possibility of hiring you.
Yeah, I actually feel this is a pretty big decision. In China, there used to be a lot of people going abroad, especially in the United States and Europe. And I guess 20 years ago, most people actually try to stay there practically. And these days, there's a rush to go back to China. So really, after doing PhD or postdoc for a few years, you're facing a huge decision. It's probably one of the biggest decisions in your career path in life, whether staying in the country that you're currently studying or doing research, or whether you go back to your homeland. Yeah, I think that depends on a lot of factors, depending on your own academic interest. I think because most of us are neuroscientists, in the field of neuroscience, there are actually opportunities either in all the countries, right? In the United States or Europe or China, or of course Japan and Korea. So maybe the decision is more on your personal choice, whether you want to be in an entirely different culture, because really the East Asian culture is so different from the Western culture. So really it's your own personal choice.
Okay, nice. Next question. Canonic question. What are your thoughts about academia versus industry, and the incentives you think steer yourself towards academia? Okay, very good question.
I probably can comment on this because I
nice.
in the industry. So it's very different. In the industry, you feel more like you're part of a massive system. So your creativity is sort of limited to your your niche in the company, because the company has a very directed goal as a whole, and that generally is driven by the productivity. While in the academia, especially if you're doing fundamental research here, I feel the very nice thing and the rewarding side of doing research is a freedom. Like you can explore pretty much anything your resource allow you to explore. Yeah, I think that's quite a huge difference.
Okay. Do you want to add anything else, Andre and Sarah?
Well, yeah, one comment specifically about the interactions between the academic environment and jobs that are related to machine learning, AI. you see a big draw of people in your lab, especially those that are computationally oriented, in always keeping an eye on those kind of positions. And it is a big discussion that we're losing a lot of people in this sense, especially the very talented one that get actively recruited. And it's obviously a battle that we're not going to win. So I think in terms of the relationship with academia, we need to start to think about better models to interact between industry, so tech companies and labs, so that it is possible to have a very healthy relationship where people can circulate and bounce back and forth between industry and academia, helping each other instead of being adversarial, like you stole my people. Or
No, I think that's absolutely right. I think, like I said, being in Korea has kind of opened my eyes to the fact that academia, especially, kind of science, or until now, it's been like, well, we don't really know how the brain works. We have to figure out first. But now it's, it's time for people who are studying the brain to kind of go out there and, interface with industry, and also for our students as well, right? Like, I feel like we should, like, labs and PIs in general should be more open to interacting with industry, because, our students need, and they can't all make it, in academia, or maybe they don't want to. They want to take this kind of knowledge and bring it to industry. And I think that's something we haven't thought about until now, because neuroscience in general has been kind of like tucked in there and kind of, in some sense. But now I think it's quite an active field to kind of, there's a lot of startups in Korea. There's, digital therapies coming out, and I think it's good for, people who are traditionally just kind of like doing research and even basic research to just start, not just interacting, but kind of jumping in there and, doing it. And in Korea, actually, there's a lot of support for that in all the universities. Like, they encourage faculty members to, like, start companies, with their students, and they'll give you support for that, and some kind of guidance. And then, so, yeah, now it's a lot more fluid, and I think, it will be more and more going forward.
Yeah, I kind of agree with Sana and Andre. Maybe like recently, I'm finding that we can borrow some of the energy from the industry to help the study in neuroscience, especially in some like AI companies. Like, they are all very interested in how to solve the problem with their AI tools. For example, if we want to study the animal or children's cognition, you need to take videos, and they can help you to find, label the behavior states based on the video data. It's very challenging for us, but it's easy for them, right? Maybe a tool to do that.
Yeah, and then now the other way too, right? Now, AI, more like brain-like AI or biological intelligence kind of inspired AI, or that kind of research is also important. So industry can also benefit from interacting a bit more closely with academia as well.
Yeah, I agree. Okay. What is your thought on collaborative work? Are they beneficial for young scientists, or is it better to do work independently so you can develop your own area? Okay, good questions. Anyone?
I think especially in cognitive and brain sciences, I mean, it itself is already interdisciplinary. So if you, right, I think you can't help but but interact in some sense. But I mean, it depends on what point of your career you're in, also, right? If you're still in the middle of developing your specialty, then kind of going all over the place and collaborating might not be what you want to do. Maybe kind of, it's like depth and breadth kind of a question, perhaps. obviously collaborations are important. And I actually noticed that in Asia, I'm not sure, but maybe it's also my kind of micro environment, but it's more like kind of lab oriented. There's a lab, and then like there's not that much interlab or inter-university collaboration. I think it's possibly because the labs are so large that within one lab there's a lot of different kinds of things that are going on within lab collaborations. But between lab collaborations can be a little bit perhaps more challenging in Asia. For me, it was a little bit like that because it's also possible that there's a bit of that like hierarchical structure in Asian academia as well, and maybe that makes it a little bit more complicated to kind of, cross institutions or areas and then go up and down a little bit of the hierarchical structure. I'm not really sure. I don't think I have an intuition for that, but the obvious answer is both. Both are important. Depends what you're doing.
Yeah, no, I agree. I mean, I think at a very general level, I would say that it is beneficial, but you have to be very careful. So it can be a distraction if you're not picking the collaboration properly. It's good to learn new skills, but they also, if they're unfocused, they're just going to slow you down. So I would say it is beneficial, but be focused. And also at a personal level, you need to find a good partner to collaborate with.
Oh yeah.
I've seen a lot of projects, collaborative projects, tanking just at a personality level. These people could not talk together. They could not interact properly together. These are factors that I would not underestimate.
Yeah, I think people's factors, people get, ignored a lot in academia. You think you don't have to, interact or really, be able to talk to and communicate with people, but that is like totally the opposite, isn't it?
Yeah, collaboration is always tough. I feel there's more collaboration in translational applied research technology development, where you really need a lot of resources. You need expertise in different disciplines. For mechanistic studies, depending on the kind of study, of course, but I think many studies are carried out by, very small groups of people. You can go pretty deep with very few people. But of course, there's always good ideas by talking to people, especially to people with very different perspective, like if they're experimentalist. And of course, you can do your analysis on your own, but if you talk to another person, either experimentalist or theoretician, you probably get very good idea from a different perspective.
Okay,
nice. Of course, collaboration, as Simon said, collaboration can be, depend on the personality.
Okay, that's about okay. How are internships? Okay, how are internships doing a PhD or postdoctor viewed from both academia and an industry perspective? Could this be an avenue in having a healthy collaborative relationship between academia and industry? Secondly, do you experience doing internship translate to actual work in industry? Very hard question this is.
Yeah, but I think it relates well to what we were discussing before.
Yeah.
And I do think that this could be, we do need a healthy relationship with industry, especially here. Borna was mentioning AI research institutes, for example. Internship, I think, is a great idea. The problem is that you have to be specific. So if you go to a company and you say, hey, why don't we collaborate? I'm interested in AI. They're going to laugh at you. You really need to propose something very tangible, or at least start a conversation along lines that are of interest to both of you. So the specificity of the project, I think, of the idea is critical for establishing a meaningful collaboration with industry, and this is very beneficial to research as well, because industry is very hands-on. They want to have deliveries. They want to have results quickly. They look at quarter reports, and so on. And that can help, actually, academics to very well define the timeline and the schedule of the project, when to deliver specific ideas. This could be in conflict with the freedom of thinking and that is characteristic of academics, but it can also be helpful. And then for the second point, I do think that, again, if the industry is a healthy industry, they will always value a lot of talent. And if you demonstrate during an internship or any kind of collaboration that you are a talented person, that for sure would translate into an actual work opportunity in industry.
Okay.
Yeah. So actually, this is really a question that people, especially in the computational side, is thinking about. For us, the big tech giant Alibaba is just right across the street, and there are people, especially in the computer science major, many students tell the PI that I'm ready for an internship in Alibaba next month. So this is something you have to, as a PI and as a student, have to think very carefully about. In my lab, I have students coming back from the industry. One student who has many years experience in the tech giant of Tencent in China. So I guess it depends on, maybe depends on the reward. Like, I guess the huge difference between industry and academia, as I mentioned earlier, is like what actually drives you. For me, I'm always curiosity driven, and I feel it's more intellectually entertaining to do research compared to the industry. Of course, in the industry, you make more money. So if your reward is actually coming from, that side, maybe that's more attractive, and that's not deniable. But really think carefully, because in the industry, especially in information technology, there's there's this barrier. You're 35 also, and after that time, you have much harder difficulty finding job once you lose your job. And this is actually a very different story in academia, because as your experience grows, you become more and more established.
And also, like, in terms of the value of internships in general, I mean, I think, like Andrea said before, depends on, whether you have like a very specific and clearly defined project, or if you're just kind of going there and, and depending on the length of this internship, I mean, I think it will like all depend on what you get out from it will be very varied. In terms of, I think there was a part of a question that I hadn't answered before, which was like, what drives you? What has been the factor that kind of has driven me to academia? And I think, basically it was what Yi said. It depends on what is your motivating factor, right? Of course, there's things like job stability, etc. But in the end, it's the day-to-day work. You have to be doing this. You're spending a lot of time at work and doing research. And so if you have that kind of, for me also, it was the curiosity driven and freedom, intellectual freedom. And my own questions that I define are interesting, right? It's a little bit, I think a lot of academics share that feeling. But at the same time, in the academia, you also have to deal with things like getting your own grants and advising students and and teaching, giving talks, doing a lot of academic kind of service work and things like that for the university. But yeah, if you're kind of like if you like this sort of time pressure and creating things, and it's okay for you to cut corners as you get things done, and it's a little bit different from the personalities that fit academia, perhaps, or you'll probably like spend like several months, investigating something and say, okay, yeah, that didn't work. Let's do something different. Let's try a different approach. And that's not going to be something that you can have the luxury of doing if you are in industry. So the things, I think the main advice is like, know yourself really well, right?
Yeah, 90% we have tried it doesn't work. I hope people in next session will have consistent and friendly opinion share with ours, because next session is the industry session.
Oh, right.
So I would like also to just specify one thing. Like I hope we're at least personally, I don't want to give the idea that in industry they just follow orders. There's no intellectual freedom and so on. I mean, I've been actually very surprised to talk to some people in industry and see how much their style is very similar to the academic one in terms of freedom of thinking and exploring and curiosity. I think the industrial model is also changing.
Yeah, absolutely.
Very good save. Okay. Any advice for young aspiring academicians? I think that's our last question. How about we finish it with this one? Okay, E. Let's begin with you. Maybe.
Can you say it again? I actually didn't get it.
Yeah. Any advice for young aspiring academicians? Like any advice, general advice, lots of advice.
Advice.
Okay.
General advice. Well, I would say just follow your heart and do whatever you're most interested in, because I feel people, as myself as a graduate student and now as a PI and seeing many different students, I feel people are in their optimal state when they're really driven. Like, you have to find out what is the most exciting thing. What is the thing that makes you feel you're in a crazy state? You can sacrifice everything for what you're working on. That actually takes quite a bit of time. When I was in the engineering discipline, you learn a lot of mathematics, and that was actually quite interesting. But then I started to do more experiments, and I find experiments are interesting as well. But eventually, I feel in neuroscience, the combination of experimental approaches and computation was something really driving me. And more importantly, the kind of question we're working on a daily basis is something that I feel very important. So that's in terms of reward, that's much more rewarding than working in the industry, even though Andrew said the industry is changing, becoming more freestyle, but I still feel in academia you have, like Sans mentioned, you have the luxury of exploring things that you can afford to change direction, but in the industry it's much more difficult.
Okay, Sang-Ha?
My advice is, like I said, kind of very, very similar to what you said and what I said before, which is like, know yourself, get to know yourself. I mean, during graduate school, try different things, understand who you are as a researcher. Academia is not for everyone. You may have some sort of fantasy about what it is like to be an academic and like a university professor. It may not. I mean, I certainly did not understand what it was to be a professor when I was a graduate student. I mean, who knew I would spend most of my time, doing public speaking and writing and doing sort of managerial, work. And I mean, and you do science some of the time, but once, as you become more and more senior level, you are managing a lab, and it's not like you're sitting in your, room all the time, just like thinking about scientific questions. And you have to deal with people all the time, you meet people. So like kind of understand who you are and understand the things that, like you said, get you up in the morning, right? Like it's hard, but you still want to do it. You find it important. You think you're pretty good at it. And if it's like, even if you fail, get rejected all the time, don't get, bogged down by that. I think in academia, a lot of times we see students who are like perfect A+ students, and they come in, they think everything has to work, and their experiments don't work, or their paper gets rejected, and they kind of get really bogged down. So you have to develop that thick skin. If you think it's worth trying again, you have to keep yourself going. Not to kind of bash on industry, but I don't want to do that, because in industry you actually kind of get stuff done. You have some products at the end, and so I think that's pretty. You're changing the world probably in a faster rate than academia oftentimes. So know who you are. My husband, he was in academia and then he dropped out and he went to law school and became a lawyer, and now he's an environmental lawyer. I mean, there's no shame in that. People think like giving up or changing something.
Back in right now. And okay. Should be able to connect. Anyway, with that said, my job here is to answer any questions that anybody might be asking in the Ask a Question section, and to sort of help the flow of conversation. And to begin, I'm actually going to have Ryota Kanai introduce himself really briefly, talk about his background in computational neuroscience and neuroscience in general, and then the transition into industry. So Ryota, please introduce yourself. Thank you for joining us.
Okay, yeah, sure, thank you. Yeah, so my academic background was more about cognitive neuroscience, although like, of course, I use more the computational methods, and I had some awareness of what was happening in computational neuroscience. And my true interest was to understand computational basis of consciousness. And yeah, so that was my academic background. And also, I had a faculty position at the University of Sussex until about 5 years ago. And yeah, so a lot of people ask why I quit academia. No, in a way, like getting a faculty position is a difficult part in academic career. But in my case, I had a permanent position, but I quit and I started my own company in Japan. So that was a huge transition. And my real motivation behind starting a company was to make neuroscience more relevant for the society. So I really enjoyed doing research, and I enjoyed publishing papers. But I also felt like publishing became just the sort of like end goal for a lot of academic research. But yeah, so yeah, in a way, like we can hack that game, but I really wanted to so make neuroscience more relevant and also useful for the society. But in a way, like that was already happening in other fields, like especially in AI, where people applied sort of like research results to solve real world problems. And maybe in neuroscience, for clinical applications, the application is very straightforward. On the other hand, I felt we could, I think I was working on neuroimaging, and I was trying to sort of predict people's personality traits and intelligence and things like that by combining MRI and machine learning. So I thought that kind of information could be useful, and people might be interested in that. So that's my original motivation. But then once I started my company, I also missed doing research. So in my company, we also do a lot of research. So actually, like we apply for grants, and we have dedicated researchers as well. So in that sense, we are trying to explore a new model of doing science outside the context of traditional academia. So that's what we are doing. And maybe just briefly about my company. So
sure,
we are considered as an AI startup, and there are so many AI startups. But in a way, my background in neuroscience kind of helps, because now people use deep learning for all kinds of solutions. But we use like deep learning, not just for like typical image recognition, but we try to use deep learning to understand like human mental states. So that's that gives us some sort of unique strengths, and also like we started combining like EEG and also like more like image recognition type deep learning, so that now we can make predictions about mental states from like external appearances. So that's what we do now.
Well, thank you. So welcome everybody. It looks like we've got some people that have now joined us after the last session, which I know is going a couple minutes late. And so what we're doing right now, I know I'm a little backlit. I'm sorry, I can't quite get in the light here. I'm on vacation with my family, so they're not very excited that I'm doing this at we're at 6 p.m. in California time right now. What we're doing right now is introductions of everybody, and then please use the Ask a Question feature. I'll be fielding some questions. You can upvote questions that you think are most relevant to you. And what we're doing is trying to understand what that transition from doing computational neuroscience research or research in related fields from the academic side is like to then transition into industry. And so with that said, I don't want to be doing the speaking. I want you to all share your insights. So I'm going to hand it over. First, we have Quintian. Can you please introduce yourself and tell us a little bit about your background? And then you, Shimizu, we'll go with you afterward. Thank you.
Sure. Hi, everyone. My name is Quinn. So I graduated from Emory about a year and a half ago, and since then has been a research engineer slash.
Uh-oh. We lost you. Are you still here? Quinn got disconnected, unfortunately. Did we lose you too? Uh-oh.
Can you hear me?
I can hear, yeah,
On, right?
I can hear you. Oh, but only brief, like only, you're cutting in and out a little bit. If nothing else, I'm really sorry. You could keep trying to connect. If you can type in the chat box, I can also try and field questions that way. But if you can, yeah, if you can still introduce yourself, we're having a hard time hearing you as well, unfortunately.
I work on Concrete, which is and
oh no, we're having a very difficult time hearing you. I'm sorry to interrupt you. We're having a very difficult time hearing. Oh no. Okay, well, unfortunately, can you try and like maybe reloading, and Ryota, there is a question, and we can try and field some questions now, I guess. Mohammed has a question, which is, how big is the market for computational neuroscience industry in Asia, and what are the most common applications that are being implemented?
Okay. Yeah, tough question. The market doesn't exist specifically for computational neuroscience. I think there's a bigger market for like general, like AI application. But yeah, but on the other hand, if you have a background in computational neuroscience, standard AI applications or implementations are kind of like, easy things to learn. So in that sense, the market is growing, and yeah, so I'm kind of reading this as kind of AI application, and there, yeah, the possibility is infinite. So in a way, people don't talk about AI so much anymore. I guess it's just granted that we all use some sort of AI applications everywhere. So yeah, so it's very
okay. So that's interesting. So in your perception, then the current market for computational neuroscience is pretty much the market of deep learning and AI. They're like a very strongly overlapped. Is that right?
Yeah, that's my impression. Yeah, so I think it depends on how you define computational neuroscience. But yeah, to me, the computational neuroscience is more science. So it doesn't like generate like engineering applications directly, but the language used is kind of the same. So like an information theoretic kind of formulation of problems and things like that
Right.
is very general. So.
Sorry, we're just asking, talking about the market size of computational neuroscience in industry. So then sort of riffing off of that idea, the skills that you learn as a computational neuroscience student, things like, programming, linear algebra, time series analysis, those skills, machine learning, are deeply relevant to industry problems, but computational neuroscience itself is maybe not a job title that you might have in many different companies. Is that the idea?
Yeah, that's my impression.
Does that seem to agree with your perception of the computational neuroscience market?
I totally agree. So computational neuroscientists, the way we understand it as neuroscientists, is I think in industry more towards a developer who knows neuroscience. So I think one has to be a little bit aware of that if you go into industry, you might be used more like a developer than a neuroscientist, while your skill set is actually the other way around. You're not a developer who can also do neuroscience, but you're a neuroscientist who can also program. But ideally, you should actually, because it's also like Ryota said, it's kind of given now that you can actually also program all these algorithms. I think people are expecting from you that you can also that you have these skills and that you can program yourself.
So Quinn, welcome back. I know that connections are unstable, and it's okay. Don't worry. This stuff happens. We're actually answering a question right now, and then we'll try and do the introductions again. But I'm curious to get your perspective as well. The question was, what's the market for computational neuroscience in industry right now in Asia very broadly? And you and Ryota had this perspective that I think is a common one. That's what we see too in a lot of places, that it's not that there are many jobs where you can get hired as a computational neuroscientist, but the skills that you learn in your studies in computational neuroscience, things like programming, software development, linear algebra, time series analysis, information theory, those kinds of things are useful skills in industry. And now, of course, more contemporary things like machine learning and deep learning are becoming part of the computational neuroscience toolkits. What is your perspective on that? Does that seem to also align with what you're seeing?
Yes, I think definitely the coding and the modeling experience helps when it comes to looking for a job in industry. But I think specifically to the neuromorphic computing area or things in this or brain machine interface, I think it's also important that my background in neuroscience also helps because I understand how the brain works. And right now there's trend going on to develop brain-inspired algorithms for like the next generation artificial intelligence, because we all know the limits of the deep learning right now. So there's that. So in that sense, neuroscience background helps too.
I have to say, from the cognitive science perspective, that's my home department at UC San Diego. I couldn't agree more. That is, you have to understand natural intelligence as well to help supplement the algorithmic development of artificial. Okay, well, we've got everybody here in between questions. Quinn, can you introduce yourself and tell us a little bit about your background and how you made that transition from your graduate studies in neuroscience into industry, if you would, please.
Yes, so actually, I was doing computer neuroscience research at Emory. So first, I was developing biophysical models for homeostatic plasticity mechanisms at the neuron and the neurocircuit level. And quickly, we discovered that there's this phenomenon that different combinations of neural and synaptic parameters, like different ionic and synaptic strings, will give you the same neural output or neural behavior. This is a phenomenon called degeneracy or degenerate coding. So later I move on from building models for homeostatic plasticity to studying the mechanisms of degenerate coding. And I think in general it belongs to this broad neural encoding, decoding, information theory kind of area, which is, I think right now is an essential piece for study brain-inspired algorithm right now, because what you do like so right now we have this spiking neural networks, which is like brain-inspired network structure that transmit information using spikes. So it's important to know how the brain encode and decode spikes in that sense, but also like for neuromorphic sensors like dynamic sensor, like they produce information in a discrete spike-like kind of style. So that helps too. Did that answer the other questions you asked me?
Yeah, absolutely. Yeah. I mean, it's not really a question, as more of a, we just want to try and get to know you a little bit, right? But I do want to, before I jump over to you, talk a little bit about, just have you talk a little bit about then, like what is your current position in industry, and like what is the work that you're focusing on now?
Yes. I was talking about that before. So right now I'm a research scientist slash.
Oh.
Oh no! I was excited. I was hoping to get that. Okay. Okay. We'll come back to Quinn. Would you please also introduce yourself?
Okay. You can still hear me, can you?
Yes.
Okay. So I don't know how far you heard, but I work for a company based in Yokohama. It's a startup that's now 3 years old. I think compared to Ryota's company, we are very much even more industry focused in the sense that we're trying to make a product that's going to be hopefully the product, which has a lot of course, side projects. But essentially, we're trying to develop a software that can help people with dementia and their carers have a better quality of life. That's very simple in a box. And my position.
Uh-oh, we lost you again.
Oh.
All right, we don't get the introductions. We lost you. The last thing we heard was in my position.
Yeah, okay.
And then we lost you.
Yeah, so my position is officially the technical director, but because we're in a startup and we only have 10 people now, and we used to have only 5 until a few months ago, it's a broad spectrum I have to do. It's like I have to I work a little bit on the strategy, on the business side, also on the strategy on what is the product that we are doing is supposed to look like. What is the AI or should the AI be behind it? What kind of data should we get so we can, after we have enough data, actually have it registered as a therapeutical product, which is our main goal, because then we can make the product really accessible for everybody. And so it's a lot of management that I do, and I hope in the future I will go back to actually hands-on things, which I prefer.
I want to come back to that topic of management. That's a really big one, because this is something that comes up a lot for people asking about that transition from, as a PhD student especially, you don't learn much about how to manage other people often. And that's a huge skill set that's difficult to learn. But briefly, now that Quinn's back, would you be able to tell us a little bit about the current job, what you're working on?
Yeah, let's see if I can finish this time before I got kicked out again. So yeah, so we have a team at Huawei that working on neuromorphic computing, from brain-inspired algorithms to software to the neuromorphic chip and materials. So I was recruited to work on the brain-inspired algorithms and eventually mapped to the neuromorphic chips we're developing. For I think we're aiming for some edge AI or IoT kind of applications.
So, there are a couple questions in the question box, but I want to try and keep this a little bit also free flowing. Thank you for doing that. We got through the introductions. This is great. I'm excited. So we learn a very particular set of skills as PhD students that are critical for our development as researchers and scientists. And then when you transition into, actually, it's honestly true of both industry jobs and academic jobs. But when you make that transition to the next step, you begin having people that you are managing, right? There are people that are working under you. You hire them, or you're trying to help direct research programs. And oftentimes that skill, and it truly is a skill of how to effectively manage people, it's not one that is explicitly taught. Did any of you get explicit training in management? And if so, what did that look like? And if not, how did you learn how to become effective managers?
Do you want to go first, real quick?
Anybody want to go first?
Okay, before, I got kicked out again. So for me, I didn't learn how to manage people explicitly in grad school, but I was kind of managing the lab, like as an informer, like a lab manager during grad school. But for the past, since I joined the Huawei's neuromorphic group, I'm working with people, with colleagues also managing interns and outsourcing people. I think to me, my experience that it's more about you focus on the project, so it's project-based management, that you know what you need to do and you break down the project into pieces
Weird.
It's okay. I'll run with that. That project management is another major skill set that people need to learn. I feel like that's also not something that's explicitly trained. But you or Yota, do you want to try and add on to what Kyun was saying?
Yeah, maybe I can go ahead. Yeah, so I really had to struggle to learn how to manage a team. That's very difficult, but in a way, it's also similar to running a lab. So probably there's no a clear distinction between academia and industry. But maybe something I had to learn by running the company was that people have very different motivations. So in academia, people want to publish papers or to research. And I understand their sort of career process. On the other hand, outside academia, the possibilities are even broader. So, and some people just don't care about finding new things, but they just want to have sort of stable life by doing things they like. So I had to adjust my sort of expectation to and understand other people's motivations in the industry. That's very different. And also maybe one small thing is in industry. For example, in my company, a lot of people came from other big Japanese companies, and so they already have methods to manage people. So basically, I learned from my colleagues how to manage a team.
Okay, so that's good. You learned it through interacting with colleagues also, which is, I mean, that's how we learn everything, I guess, right? It's very hard to learn management from a book, I guess.
Yeah.
Do you want to, oh, sorry, go ahead.
Yeah, I think, Ryota is right. It's like being a PI, but I do think that there are very few PIs who are very good at management. And it's fair enough, because research is usually, if you're a researcher, you're usually a researcher because you like to do your own thing. And there are many people who are not very good team players. And of course, everybody's researching their own thing, but within that, you have your own spot. While in a company, you might, if depending on the company, you will have to work in a group. For example, in our case, we have 3 software engineers who work on one software. So you cannot like fiddle around that. Oh, today I did this to do that. And to manage that, that's my job at the moment, but that's really, really hard because they're different types of people, they're different. But it's also hard to manage, I think, to be a PI. In my case, I just learned the management through being a group leader. That was really, really hard. And having too many projects without enough people. And it happened that I went into industry because of that, because my PI was like, you would be ideal for this startup. And I was interested. But I have to say management is something I think people should be prepared for. Also, even if they don't want to be in management, to be prepared to be a team player, to communicate and try to find out what motivates the others, like you said. What can I do? You have to work with it. That's very different, I think, from academia.
So there's the component of, it sounds like you're talking about also just empathy and interpersonal understanding about what people are looking to try and do. Is that one component? In addition to the, please go ahead.
Because it's not your own paper that you're going to write and that it's finished.
Right.
It's going to be something that should be there for the company. So you have to align with the company dream, more or less. I mean, of course, the bigger the company becomes, the less important it becomes, maybe. But in for example, because we are only 10, you can see really the big differences in what the product should look like, and is that really right or is that really wrong? And we have the nice culture in our company that we can say whatever we want, even to the boss. But it also turns out the other way around sometimes. It turns out like some people go totally derail sometimes and think, oh, this is totally not what we should be doing. But that's not the place to say it in that sense. In research, you can suddenly say, okay, I'm changing my mind completely.
I think that's a major difference that I see in the students that I work with, both in academic side and then in the industry side, is the changing the way you think about problems as being your own problems or your lab's research problems to what are the things that I can do to best help the company move forward on its goals. And so rather than working on, the small group, your lab, your PI, your own thesis, whatever it is, your own research project, now you have to think about, how do I think about business problems and how do I translate the work that I'm doing into something that is most useful for the company, as well as, of course, for your career and those around you. So going back to one of the other topics that have come up, and then I want to start answering some of the questions that people are asking in the poll. Project management is another key component of this, which is how do you keep track of what has worked and what isn't working on the projects that you're doing. And I feel like when I speak to students, a lot of the project management is almost in their own head. They don't have explicit project management. They're not writing things down as well as they should be necessarily. I teach my students how to use like, Kanban, agile programming and that kind of stuff, right? Like very explicit project management software and techniques. But that's not common in industry, right? That came from my industry, it's not common in academia. That came from my industry training. And I feel like that helps my academic side. How do you all then take people to learn the project management to make them more effective at their jobs? And do you see any utility of that for people working on their PhDs or in industry in general, or in academia in general? Anybody want to take Ryota or Kyun, maybe because you have this 5-minute window, maybe?
If I understand your question, you're asking about like specific methodologies or tools that help with project management.
Yeah, how do you leverage project management to make your job and the job for those people that you manage better?
Okay, so I think first, like in grad school, so as a grad student, sometimes you got to supervise master students or undergrads. that experience definitely helps because, okay, the big background at Huawei is that I'm working at this research lab called 2012 Lab, which named after this 2012 movie back then when people think it's the end of the world kind of thing. But so this research is focused mainly on future technologies, and about at least 60-70% of people here are having a PhD degree. So here is more about like research focusing on the next 5 to 10 years. In that sense, is more like academic research than like any immediate like product like thing. So under this background, my experience was project as management in grad school definitely helps when it comes to like the experience with managing master students and undergrad transfer to interns and even like outsourcing colleagues. And but I think the most important thing that you got to learn like to first you know like manage yourself, like your own project. Like can you have a clear goal and like a timeline and what to do, and you know all the when things go wrong, like how to fix it before you know like distribute that to other people. So I think that's important that you got to keep honing that skill in grad school, and how to better manage your own project for both research and you know like industry related activities.
If nobody else has any other additions to that, there are quite a number of questions we can get to. So currently, oh, and we lost you. I'll type the question also in the chat box so maybe people can see it. But so the first question is, compared to your academic experience, how flexible are the types of scientific questions that you work on in industry? Ryota, do you want to? I mean, you have that sort of running a lab and.
Yeah. Well, yeah. I guess it depends on the company. So, yeah, maybe in a like smaller company, you know, you might have more flexibility, or maybe you can have more influence on the direction of the company. So, in that sense, you know, you can, you know, well, yeah. I think there's some flexibility, but maybe in big companies they have like specific goals. So in that sense, there may not be much flexibility in terms of scientific questions. But on the other hand, even in industry, there's a way to sort of align business with your scientific interests. So for example, like in my case, when we approach clients, we explain what we do, and then actually like explanation of what we do includes the kind of scientific questions we want to ask. So in a way, what we like really trying to do is to sort of connect business and science, and especially, well, in a way, it's almost like a grant proposal. So we propose some projects to our clients, and then but of course we want to include what we are good at, and then that's a way to sort of insert our scientific interest in business projects. So it is possible, but you have to have a kind of holistic perspective. And that's my answer.
That goes back to the conversation we had earlier about figuring out, in at least in the US, in the startup culture and business in general, we talk about what are the KPIs, the key performance indicators, right? And so teaching people who come from a research background to then think about that, not only have their own interests that they have to pursue or that they'd like to pursue, but then there are the business interests that they have to pursue. And at the end of the day, that is what they're paid to do, usually, is to try and maximize the KPIs, improve the business, right? I don't know, you or Kin, do you have any
I think this
comments or additions to that?
This is a very important question, actually, that leads to something else, which is that before you apply, or even during your interview, you should always find out what the company really is doing and what your role is going to be, because I think it really depends on the company how much flexibility you have. You always have flexibility within the question that the client has, right? So like in our case, it's like improving quality of life for people with dementia. So from my point of view, that's finding out which brain areas are affected by which part. But within that, you have a lot of flexibility, right? And the second question is, does the company provide you that flexibility? So when my suggestion would be find out how the company works, ideally through talking to somebody who already works there. And if you don't have that chance during the interview, you get asked many questions, but you also can ask. So ask, maybe not how many days of holidays do I have or something, but try to find out how they work. Do they work in teams? Do they work on one question, but within that question they have flexibility. So I think this is very important. Every company is different there. I think it's very. I happen to have a student actually I used to mentor that who works at Ryota's company now. So that's why I'm a bit familiar with how he works and how we work. It's completely different. Yeah, maybe I'm very good. We're still in touch. We're very close actually.
Okay, there's another question then, which is, what are some of the usual skills that are missing in people coming from PhDs in computational neuroscience that are required in industry? I feel like we've touched on some of those already a little bit. Project management in general, management of people.
Yeah, right.
But are there other skills? Okay, let me phrase that another way, because this is something I tend to see. Are there bad habits that people learn from their PhD that have to be unlearned when they're working in industry?
Yeah, I have one. So maybe it's related to the discussion on project management. So people who came from PhD program tend to have no timeline or no clear plan in terms of schedules. On the other hand, like in industry, like we have like really clear deadline. So that's the difference. So when you're working on your own project, I think like most scientists work as hard as they can until they get the result. But then typically there's a lot of uncertainty in research. So they don't have like clear idea like when they publish a paper or when they finish some simulation, things like that. So that kind of mindset needs to be changed. So they need to deliver things in time. So that's a huge difference from or maybe like in general like academia and industry.
Yeah, I think that I struggled actually with that. I think many researchers have. Sorry if I generalize that, but we have the habit to do everything in the last minute, the day before or the night before. That doesn't work so well anymore because you have to kind of let people know before you actually finish, so they can give their input or feedback. I struggle a lot. I struggle also with writing down things. I don't write things down. I have to, even though I manage the team, I don't write things down. We do use Jira and Kanban, like you said, but I hate doing it. I just do it so the team doesn't struggle. I don't I don't know why, but I don't feel it's necessary for myself, even though I should be doing it. Especially for version tracking, actually, you would need it. You don't need it. So from my experience so far, also because we're a small company, you don't really need it to track what you did or didn't do. In the software development, you need to track who did what. So, and that's when it becomes really important. But I myself, I'm really bad at that. Also, using Git is a special skill that you should learn probably. Version tracking of your software, writing clean code. That's also none of my strong skills. I just write whatever I write. And then afterwards, of course, you don't have time to rewrite it, which you always want to do afterwards, and you never do. So these are things you have to kind of think in before you start doing something. You have to kind of force. I mean, I try to force myself to think about it. Yeah.
And I think that's the power of something like a formal project management approach like Kanban, which is you may not like it, but it forces you at the beginning to think about what are the end goals for the project, and then work backwards and break that into manageable steps that people can easily take and work with without very constant micromanagement from somebody that is guiding the team.
Yeah. Also,
And so the two software management things that people talk about is GitHub or Git in general. GitHub is a approach, right, for working with Git, and then Kanban, as somebody put in here, it's not a software, it's approach, and Jira is exactly right. Yeah. So thank you, Manisha is all over it in the chat.
Yeah, Gantt chart is also something you have to get used to. It's scary because there's so many deadlines. It's like, oh my god, there's so many deadlines. But you need to, I think, also mentally get prepared to that there are always deadlines and what to do if you cannot meet them. But you get used to it. I try to. I mean, I don't think it's a bad thing. I just don't like it. But I do see that it's necessary. It is absolutely necessary.
When I teach my students, I don't tell them to write good code and clean code for other people, as people are talking about in the chat, if for nothing else than for your future self, right? It's very easy to be deep in the code and to be deep in the algorithm development, and you kind of, after struggling, come up with a really good solution that finally works. And then you're being very clever about it, and it might be a complex solution, and then you leave and come back to it 6 months later, and you look at your own code that you wrote, and you don't remember how things worked, and you have to spend extra time, right? And so if nothing else, save future you a headache by doing good documentation of your code, right? We also want to help, of course, everybody else working on the project, but it also saves you a headache.
Maybe to relate to that.
Yeah, please.
Do you want to go ahead with the next question, or?
Nope. No.
So related to that, I think it's also important to learn how to communicate why things are going the way they're going to whoever you have to report. So I find it sometimes very difficult, especially with this. We have somebody else who codes for us from outside, and if we are slow with integrating that in our code, sometimes we get the question, why is it not done? And so you need to get used to also, in simple words, explain why are things not working the way they're working. For example, in our case, it was exactly the case that the code was so illegible that it was difficult to integrate. But that's for our boss who doesn't code. It was like, I don't understand what's going wrong. You just put it in there, right? So you need to kind of, it's a pride thing, so you need to kind of not take it as an offense. I tend to feel like attacked when somebody says that, because I always think I do my best, so I feel attacked if somebody says, why is it not working? It's like, because I have a problem, right? So you need to kind of be able to frame that problem and make that person understand that it is really something that takes time. It's not something that you have been lazy or you didn't take care of. Oops,
we lost again. Okay, all right. Well, we'll continue on. I'll put the question in the chat again. So it says, we're going to go with this question here. Many of you spent many years studying and living abroad. Was there a big culture shock when you got back to your home countries, and how did you cope with that? Anybody?
Yeah, for me, I went to United States for college when I was 18 and stayed there for PhD. So that was 10 years in the United States before I came back to China. Well, I don't see that a culture shock. It's mainly about things I mean, the way, like the social, the way you like socialize with people here, that's something that doesn't change like easily, but it's mainly about the industry trend and how people are focusing more and more on innovation and creativity, and focusing more on developing technology. So that kind of like impresses me. So it's I think it's yeah. So short answer is no. Yeah. But maybe it's because for me, like personally, I'm quite independent and quite adaptive. I mean, going to the United States at 18 really helps, being like, adapting to the environment quickly. But the workload here is actually much stronger than in grad school that I have to adjust to. So I think there's
The workload increased
Yeah.
from grad school.
Yep. Believe it or not.
I believe it. Yeah. You, Ryota, do you have any? What are your perspectives on that?
Yeah, with well, culture shock in the sense I grew up in Austria, and I lived there until I finished my PhD. So, of course, because my parents are Japanese and we came over every second year, the culture shock itself was not so big, but the system, the university system, was hard for me. In the end, the reason why I'm now in computational neuroscience is because the postdoc system wasn't that established when I came to Japan. So I was the only postdoc in that place, and essentially professors didn't know what to do with me because there wasn't such a thing as what is this person doing who is just doing research and not teaching or anything, or she can do a TA, but we don't know what to do with this person. And for my development, I think that was a disadvantage. It was maybe an advantage because I learned to kind of try and be independent. So I started looking for different jobs and gained a lot of experience in different places. And what the other thing is what Quinn mentioned, the workload is definitely much bigger because there is no up and down in the universities. In Austria, we have definitely summer holidays, even if you're a professor, researcher, whatever, definitely winter holidays, 2-3 weeks. And everybody's off. There is no such in my company we can also take off, but because everybody's always working all the time, you always feel like you're delayed when you come back after a week or two. But in Austria we have definitely everybody takes off summer and winter, so there's kind of a natural up and down. And I struggle actually health-wise and mentally under that permanent work style after 5, 6, 7 years. I mean, in the beginning I didn't feel that I was young enough, I guess, to get over it. Yeah. And one other thing is, of course, the gender gap. I felt that very strongly. I'm not sure in Austria it might be the same because I don't have any experience in Austria. But if you're in a management position as a woman, you go somewhere with your technician who is a guy, they will talk to the technician. They will not talk to you. You are not the first person they talk to. And that very frustrated me a lot. And that's one reason I actually started working in the company I do now, because there is no such thing. I feel like I'm accepted, even though I'm in a computational area, which is not supposed to be an area for women, or in software development. I feel like they fully accept my opinion, and I don't have to go out to other companies to talk to them because they know I don't like that. I feel it's too much stress to kind of defend my position as a woman in a management. It's like, I just don't go there. If they don't want to talk to me, that's fine. I just stay where I feel comfortable. So I think that's maybe the wrong decision, I don't know, but that's one of the things that I think might be stronger in Japan than in Europe. But they're changing, and I'm counting on all the women who come out.
Yeah, unfortunately, it doesn't seem to be a restricted to any one place kind of phenomenon.
Yes.
See that, quite a few places, of course, unfortunately. But I think it does seem to be changing in some places. I don't know about everywhere. Ryota, do you have anything to add on to that?
Yeah, well, in my case, maybe multiple things changed at the same time. So like when I moved back to Japan, I also switched from academia to industry. So yeah, so the cultural difference was not just about the country, but and also the work style and many other things. Also, like I switched from neuroscience to machine learning, so that's like another cultural difference. So yeah, but yeah, I guess well, in a way, like I struggled a lot because like I never had like a business experience in Japan, so I didn't know it was about Japan or business, but then I felt foreign to those things, and yeah, but on the other hand, okay, so maybe a big difference in Japan is that people are very homogeneous, so they can mostly um, yeah, mostly Japanese men. So yeah, whereas like maybe maybe it's more so in academia, but when you are like working in an English-speaking country, like your colleagues are from everywhere, and yeah, so I was more used to international gender balance situation. So that's a big change. But on the other hand, because of the COVID, now I feel that there's no real difference where you work. So yeah, like even now, like we have this kind of meeting, and also yeah, even in my like everyday meetings, maybe like half of my meetings are international, and yeah, I guess the only factor is just time zone. So otherwise, I don't see much difference. Maybe the only difference is when you go out, you see like different sceneries depending on where you are. But otherwise, like I feel now we can work from anywhere, and yeah. So in that sense, maybe I guess like we also kind of hire people from abroad, and then because they can't travel right now, so they work from home, like from different countries. So I think that kind of work style will become the norm, and once that happens, maybe it doesn't matter so much where you in which country you work. But that's my idealistic future prediction.
Welcome back.
I'm really sorry about network glitches. It's kind of regular, but it sucks. What was the question?
I was muted.
Yeah.
No, I wish we had one platform that worked smoothly for everybody, but yeah, such is the nature of the technological COVID world that we're living in. I guess to branch off of Ryota, it's empowered us to do a lot of things, but it has its glitches. All right, we have enough time for one more question, and so I guess we'll close it out on. I like this one. How closely related are your PhD subjects, the topics that you did your research in, to the types of questions that you answer in industry? So when we began, we talked about the methodological overlaps between what you learn in computational neuroscience and the job that you're doing now. And so the last part of this question is, the first part was, how closely related are your subjects to the type of questions you're doing now in industry? And the second part is, are you mainly bringing over that methodological knowledge, or does your scientific background play a role as well? I love this question. Quinn, do you want to go before we might lose you?
Yeah. To me, I think again it depends on the industry and the topic, the area you're working on, but also the company. So for my work, we have this flexibility to explore what kind of brand inspirations we want to draw from. So the work I did in PhD actually quite relate to what I'm doing right now. Like for example, like homeostatic plasticity mechanisms about how the brain copes with disturbations and recover its neural activities after some internal external damage, and that can be applied to making the system or the neural algorithm more robust to, for example, like adversarial attack. And it has been implemented in some neuromorphic chip design too. So, but that really depends on, like both the work style at the company and the specific area you go into.
That's helpful. I don't have a follow-up. I'm just now wondering if anybody else has anything to follow up or they have a different perspective.
Yeah. Okay.
So
maybe
yeah, like, go ahead.
Oh, okay. Yeah, so in my case, my PhD subject is not really related to what I do now, but I think in general, the process of going through a PhD is like really useful. So I think that proved that person went through the process of like learning a lot of things about one topic, and so including like reading most recent papers, and also PhD implies the ability to independently do research to like generate new ideas or new inventions. So I think that kind of experience is very valuable. So and also like in industry, it's essential to be able to learn quickly and get the accurate knowledge about what's possible in science and technology. So that's a very crucial skill. And yeah, so in that sense, I think there's kind of a general set of skills like PhDs gain through their programs.
Yeah, so I think what Kyoto is trying to say is that you shouldn't be afraid that you're studying something that you won't use afterwards. It is definitely of use what you do. Like in my case, my original PhD is in MRI image reconstruction. Has nothing to do with, I wouldn't say nothing, but it's physics and applied mathematics, but it's data analysis, it's imaging that has to do with brain, and it naturally led me into neuroscience, computational neuroscience and science, because that's how the development of the computers and the data science happened. At that time, there was no such thing as computational neuroscience, unfortunately. But yeah, so I think you should not be so worried about what you're studying now, what you're going to study, because it will naturally lead you to something that interests you, and you will always be able to use whatever skills you learn in your PhD. I think there's, depends on which job you're applying for, but you will hopefully apply for something that interests you. So you should be taken care of, I think. Sorry, Quim, I interrupted you there.
No, I just want to like make a comment about that. I think people ask this question because they wonder about like whether topics studying grad school will be really useful after they graduate, like especially when they go into industry. So from what I can see from now, like there are definitely some topics that have broader applications. Like if you study like vision mechanisms that can easily be applied to computer vision or brain-inspired vision algorithms. Similarly for like learning and memory mechanisms. But even for like some quite like we see like minor areas, like not minor, but just some like like peculiar or interesting minor thing. Like, for example, like insect-inspired AI is also a topic we're like exploring right now, even though it's like there are less people trying to learn from like insect, like how they there's like a trend applying insect-inspired navigation system to, for example, like self-driving systems. So it's more about how you draw the link yourself to what you study in grad school to real world problems. But overall, there's definitely some topic that can be applied to real world problem easier than others. But there's always a link. You just have to find it.
Well, we are out of time. I don't want to go too much longer, unfortunately. I feel like there are enough questions and topics that we could do this for a lot longer. Geez, I've been trying to fix my backlighting the entire time, and the sun's going down here, and I can't, I can't fix it. I'm sorry, but thank you everybody for taking your time this morning for you all to do this on a weekend, especially. There are a lot of people here that are watching. And we'll be watching this on the recording, for whom this is very valuable. right? As this last question indicates, and as you all touched upon, a lot of people are very worried about how they're spending their time in their education, right? These are critical years for a lot of people. And hopefully this gives them some confidence moving forward that this is, a useful set of skills that they're learning that are broadly applicable to their careers, whatever they may be. And with that said,